Cape Cod is an inspiration for innovation. eSTEAMers will introduce you to the often overlooked entrepreneurs who are building Cape Cod's future with STEAM. Join us on the journey as we discover the makers, the innovators, the educators and artists who are creating the new economy on the sandbar. Welcome to eSTEAMers. Today, we're talking innovation. There's old problems on Cape Cod, but there's new ways of actually working with them and solving them. Today, I'm with Brian Bragington-Smith from Lewis Bay Research Center. Brian, welcome to the show. You're doing some really cool stuff. Give us I'd say a short overview of it, but I know you well. How about a quick overview of what Lewis Bay Research Center is?
Well, the Research Center was formed somewhere around the millennium shift, and we actually incorporated, became a formal entity in 2006. And the Research Center was put together in order to be able to come up with the science and the documentation on what's going on in our coastal ecosystems. Because as a native Cape Codder, someone who grew up on Lewis Bay and has been scuba diving since 1967, you know, I've seen the changes. In fact, knowing those changes, seeing those changes, which are only apparent once you go below the surface, it became painfully clear that something was happening in our coastal waters, and it was something that bothered me enough to motivate me to commit my effort to make it happen. And so myself and a close friend and now associate, Rulon Wilcox, had a similar vision. And he's been involved in oyster aquaculture for the past 30 years. He's one of the grandfathers of oyster aquaculture here on Cape Cod. And of course, he was intimately familiar with what was going on, and our level of concern motivated us to join forces. So we formed this 501c3 nonprofit, and its mission is to conduct ongoing research in the coastal ocean interface with the land, try to come up with answers as to what some of those problems are. Okay. And then also try to bring about the resolution or the solution of those problems by, you know, creative means. So to that end, and over the past, you know, crying out loud, it's coming up on, you know, the better part of 20 years, we've been able to do quite a bit. Probably the most exciting is that we now have a research laboratory, a physical laboratory at the old Zaquarium in Parkers River.
Right. Yep.
And we've been studying algae there in particular, and sustainable agriculture. And what happened was that initially, as a result of the research and the experience of watching the shift in the benthic organisms, the algae coming in and infesting the bottom, algae was a nemesis of mine, you know, because it was the harbinger of doom, really. Doom. Fish kills, you know, the declining environment, you know, sort of the gateway to hell. I mean, you know, that's really kind of what it looks like when you're down there. And so my motivation was, you know, that this was the intruder, and so we were trying to figure out how to eradicate it, how to deal with it as a crisis. And you know, it's kind of funny because innovation, you know, like many other things, happens, you know, just by being there. It's something that may or may not have been planned, but results from a eureka. And the eureka that we're dealing with here is recognizing that the algae really is one of the most important tools in Mother Nature's toolbox. You know, she isn't throwing algae out there to harass us. She's throwing algae out there because it's one of the most important and useful tools in removing the nutrients from the water. Okay. In fact, if you look at it, algae was the tool that nature used in order to convert convert our planet from a toxic orb of carbon dioxide, methane,
Correct, yes.
and acidic water to one that has an atmosphere that's now 70% nitrogen, 21% oxygen, and those other elements are kind of trace elements. Over the millennia, those tiny microorganisms converted our entire atmosphere. Now, looking at that, and now all of a sudden recognizing that there's really this balance between, our more, the complex organic organisms that, humankind is part of, and the microscopic world. And with both, the algae and the bacteria and the fungus, all of these things work in concert to create a dynamic balance. So what we recognized in the algae then was that, well, if this algae is the natural solution, if it's what Mother Nature is using, right. And by the way, we use macroalgae was the original topic, and what we were studying, which is ulva and enteromorpha, the blue-green algae, we had put together a platform to try to harvest these, to remove the nutrients from the water before they, died and caused the problem. Well, what happened was, as the coastal water quality deteriorates, the algae shift. And so what ended up happening is it went from macroalgae to microalgae. Okay. Now, the microalgae is plankton. So basically, the reason that it's able to outcompete its leafy brethren is that it can float in the water. So what does this mean? It has the ability to go to the surface to really get the sunlight. Well, once it's up there, according to the science that we've been able to accrue, light can only penetrate about 3 inches in a fairly dense algae bloom. So anything below that is starved for light. That's why the algae was dying, is because it was not getting sunlight. When we looked at the microalgae, what we realized is that by taking that and working with it as a resource, or in a way as an agricultural process, and feeding it wastewater, right. It totally eliminates the nitrogen. And I'm not talking about it reduces the nitrogen. I'm talking about totally eliminating the nitrogen. Now, the really cool part of this, another one of these innovative eureka moments, is that this is basically just the photosynthetic process. It's all it is. It's been here since the beginning of time, and it's a very simple process where sunlight stimulates a chloroplast in a green leafy plant. That takes in sugars, converts them carbon, and converts it into sugars, and that's with nutrients. And it has a specific capacity to be able to convert carbon dioxide into water. And oxygen. So in an aquatic environment, that means that you're ending up with water, but more importantly, you're ending up with oxygen. And it turns out that as an innovation, in our wastewater treatment, basically oxygen is the most important element. And it takes roughly 7 pounds of oxygen to remove 1 pound of nitrogen and 1 pound of biological oxygen demand, or bacterial organic contamination. So in today's world, what is used is people put in these great big blowers that take the air and they push it into the wastewater with the hope of being able to get enough of that 21% of the air, the oxygen, into the water so that the bacteria that do the work of digesting the organics have the oxygen to breathe. And that's a very expensive process. Not only is it significant from a standpoint of you have to pay for it when you build your plant, but really it's roughly 60 to 70% of the operating budget of a wastewater facility, because you have to keep pumping that oxygen through the water. Well, if you take the water that you end up with as a result of harvesting that algae, that water is supersaturated with oxygen, as much as 700%. That oxygen is available for the bacteria in a much more readily available way than you would get in an aeration system. What we're doing is taking that water and putting it back in at the front of the wastewater facility. It totally eliminates the need for aeration. So in essence, what we're doing is taking that natural solution in the form of the microalgae. We're using it to totally eliminate the nutrients, which are the problem in the coastal environment. And as a byproduct, we end up with the oxygen, which is life-giving. We're consuming 2 pounds of every of carbon dioxide for every pound of oxygen that we create. So in essence, we're taking on the role of the planetary restoration tool that Mother Nature used eons ago.
Sure.
And we're also mitigating global warming, carbon dioxide. So by integrating this and by applying this as a wastewater solution, we're really solving a couple of different problems. Yeah. The real cool thing about it is that algae and that the organic waste from the wastewater process is then digested, turned into methane, and is used to generate electricity. Now we're taking the CO2 from the exhaust and we're feeding the algae, the CO2, so we have no exhaust gas effluent, nothing relative to greenhouse gases. And the facility ends up being kind of self-perpetuating. It's off the grid. Right. So instead of having something where our communities end up having to pay dearly and basically pay to solve a problem, we take that problem and turn it into an opportunity. And it was done as a result of the research that was conducted by the nonprofit Lewis Bay Research Center. This gave us the knowledge of the algae, which of course, as I had mentioned, had been a nemesis and turned out to be the biggest friend we could possibly find. So as it relates to the bigger picture of what you guys are talking about, the Cape has many different problems that we're facing right now. Coastal pollution is a very big one. Affordable housing is another one. And jobs. Jobs, you know, good Cape Cod-based jobs that our kids are going to be able to sustain themselves on are the critical keystone components. What this represents is an infrastructure solution which is Cape Cod based, which also produces the potential for career path opportunities for students. And they can go from secondary education directly into the field, or they can go into the field and continue education as a lifelong process, or they can go to further their knowledge and get those advanced degrees, which then allow them to participate on a higher order level in the same industry. So to me, the really exciting point here is that there is the opportunity for innovation. It's open to everyone, and oftentimes it's in trying to answer another question that you find the answer to an even more pressing issue. So to me, it's very exciting stuff, and I guess in an attempt to compress it, as you had asked, I think that pretty much says it.
Right. I know that we're going to see some footage in this program a little bit later of the, I guess you could call it an algae factory.
Well, that's what it is. In fact, the interesting thing about it, and Greg Watson, who up until recently was the Secretary of Agriculture in Massachusetts, he also has an extensive background in renewable energy and sustainable farming. Anyway, he came by the facility because he's a close friend and he was interested in what I was doing. And after touring the facility, he said, this is an agricultural operation, it's not a wastewater treatment operation. I said, well, that's not necessarily, right. This is what we're going to be doing with this. And he said, no. He said, you are taking a plant, and you are planting the plant, and you are nurturing it with the effluent or the byproducts of our community, which is something that's been done since the beginning of time, at the very start of agriculture. You're growing that plant, multiplying the numbers, you're harvesting that plant as an agricultural product. The fact that it's a microscopic plant is the only difference between that and lettuce. So you are an agricultural process, you are a farming operation.
Whole another word, hydroponics, doesn't it?
well, actually, what we do is an interesting additional point, is that lettuce loves oxygen. So what we do is we aren't discharging anything at our laboratory. We're growing our algae, we're harvesting our algae, we then take the water and supply it to a aquaponic system where we grow lettuce and Italian kale and red leaf lettuce. It's absolutely delicious, and it grows like mad because it has this oxygen-rich water. So the net on it is that we never discharge a drop, because evapotranspiration through the leaves of the plants, taken up as it as it consumes that oxygen and nutrients, it totally eliminates the water discharge.
That's great.
It's amazing, and actually the cool thing is when you see some of the footage, you'll see that there's an advanced algae photobioreactor, which is actually the containment vessel, if you will. It's the farm for the algae, and it's the largest one on the East Coast right now, and I think it's a really cool thing. But we also have the lettuce, and that facility is intended to become a vehicle for the STEM platform, across the Cape, where students will be able to come in, and by really getting a chance to be able to see Mother Nature in operation, and that's actually what you're watching as you watch the photobioreactor process. All of a sudden, the whole photosynthetic process, the whole dynamic of the natural biological processes becomes absolutely crystal clear. Right. And it's kind of like a gateway to enlightenment on science, as kind of a fun thing to do. And one of the things that we oftentimes, quote in our activities over at the lab is something that Einstein said, and that is that knowledge is the aggregate that we already know. That imagination and innovation are the gateway to what we will know. And so that's why those are actually more important than just the aggregate knowledge base, because he also said that never really bother to research anything that's already written down because it's already there.
It's already there.
So
exactly.
Anyway, that's kind of a little pearl of wisdom for your necklace of knowledge. But
I like that.
But it's something that I find inspiring.
Yeah. Well, we'll have you back obviously on the show because I know you're doing great things out there, and the footage that we have, I think we actually have a time lapse of some of that algae growth.
You have the footage, and this is significant. You have the footage of the initial inoculation of the photobioreactor when it was first turned on, and that footage that shows that algae rushing into the vertical bioreactor is so cool. And I actually will look forward to watching the program just because you're going to have that in it.
Excellent.
I'll turn it down when I'm talking because I bore myself. But anyway, I thank you for this opportunity and,
thank you,
and
Brian.
to work with you. I thank you for what you're doing.
Yeah, no, we're going to be looking forward to other things, innovation here on the Cape. I'm Paula Hersey, and this is eSTEAMers.
Hi, this is Chris Connors, and this is eSTEAMers, and we're talking about drones and remote control flying devices today. Hi, my name is Chris Connors, and I'm here at the Cape Cod Media Center with Kent Cannonberg from Discover RC Flying.
Discover RC Flying, we fly out of Marston's Mills, Barnstable Airport. We have a wonderful grass landing strip there, nice sized field. Our field and our club is AMA sanctioned. AMA is the national sanctioning body.
A whole bunch of drones on the table. Are they drones or are they remote control?
Well, there's a lot of controversy. I think people are coming around to the people that are flyers. We've always kind of traditionally hated the term drones because of the military connection and all that, but we've come to realize that that's what the general public knows it as, so we're getting to be okay with that.
But a drone is it flies by programming, and a remote control is one where the operator controls it?
Yes. Well, I think even the military drones are they can fly autonomously, but the technical term is unmanned aerial vehicle. That's what the FAA refers to any of these things. So anyhow, most of the people at our club fly what we refer to as fixed wing, this would be an example. This is kind of a general foam airplane, kind of designed as a glider. This it is an electric motor. which you can get the plane up to altitude, and then generally you just cut the motor and try to find thermals and fly around. It's not a pure glider per se, but it's so you get a lot of flight time with something like this. Average flight time for a regular remote-controlled airplane is in the 6, 7, 8 minute range. This I can fly 20 minutes to a half an hour by cutting the motor down and just gliding. It's a good gliding plane. I have this plane set up. The reason I brought it, I have it set up for what's known as FPV, which stands for first person view. And the basic equipment is a set of goggles. There are two basically little TV screens inside, one for each eyeball. These are worn like this. And you'll see the little antenna, there's a battery. And
then there's an antenna on the plane itself.
That's correct. This is the camera. And there's a radio transmitter here which takes the signal from the camera and transmits it through this antenna to a receiver that's built right into the goggles. So essentially, when I'm flying this plane, FPV, what I'm seeing is what this camera is seeing. So it's a completely different experience flying the plane FPV.
Because you're flying as the pilot.
You're flying as the pilot, that's right, and totally different experience. Generally speaking, when you fly this, you're standing on the ground and you're viewing something that's away from you, and I'm going to come over here and get my controller. This is the controller or radio or transmitter that's used to control that airplane or this quadcopter or basically any number of airplanes. And it's done with using thumb controls, and there's a number of different switches that control various aspects of the airplane as you're flying it. Very sophisticated devices, and so it takes. I have been in the hobby. I started a year ago, December, so I've only been in it about 14 months, and but I've really fast-tracked this. I've just absolutely fallen in love with this, become very passionate about it. I own 27 airplanes of all different styles and kinds, and I'm still really learning to fly, and in the process, you crash. So one of the reasons that whenever I go to the field, I usually bring 5 or 6 or 7 airplanes, because invariably one of them isn't coming home, or it's coming home in pieces. The nice thing about it is you can generally fix them.
I'm here at the Cape Cod Media Center with Charlie from Discover Flying.
Yes, this is a very inexpensive quadcopter that less than $50, and has full control. It has lights. It actually has a camera. It's a very inexpensive camera. The camera does not move. I can show you the camera. This is a camera. It mounts on the bottom of the copter, and you have to drive the copter around to get the picture you want. So very little sophistication, but very cheap price. Very nice starter kit. Comes with a controller. Does a whole bunch of, does anything you can think of.
Helicopter?
The helicopter is really a very small package that's very, very sophisticated. It has a lot of very complex controls in there. There's a lot of electronics going on. It has 2 gyros. It has 3 servos. It can fly upside down. It can do anything that your imagination could think of, and then probably a little bit more. All the parts are totally replaceable. You can buy them at the local hobby shop. This is the controller that controls it. It has a lot of sophisticated buttons and whatnot, and we utilize all those buttons to fly that little piece of machinery. And it's actually a very rugged piece of equipment. It's made of carbon fiber and can take a pretty good beating and still keep on ticking.
So my suspicion is that this helicopter might be a little bit more than the $50 one here?
Yes, it is, but fairly inexpensive. You get all of this, for the helicopter alone, it's about $150. So not, again, a whole lot of sophistication for not a whole lot of money. The radio is a $300 piece of equipment, but you could control that helicopter with a cheaper radio. Yeah.
And also this radio could be used for other...
Yes, this particular radio will hold 20 airplanes or helicopters. The newer versions of this will hold up to 250, and it has an SD card that you can put in your computer and put a whole nother 250 on that card and save the ones on the computer. So the sky's the limit with the electronic equipment.
Okay, hi, I'm here at the Cape Cod Media Center, and you're John?
John Strom, and I'm from Discover Flying RC Club, and I brought my DJ Phantom 2 in today.
That's great. And tell us a little bit about this.
This basically is an aerial photography system. What we do with this is we can take really good aerial pictures of beaches, of houses, of any number of things that you want to take up in the air. And it's just an awesome photography system.
So this has like a stabilizer on the camera?
Yes, it's got a stabilizer on the camera, and this is a GoPro Hero 3 Plus. You can see. And you'll see the gimbal initialize. There we go. And it's still doing it. I just need to do a little bit of software work with the camera gimbal. You can see when you're flying, as the drone makes attitude changes, that the gimbal keeps the camera straight and level, and that's what the gimbal's for. Is that you may have a good pitch or a banking turn, and yet the camera basically stays in a level attitude so that you get good footage with your video. And then there's a mini SD card in the GoPro Hero. I'm sure many people know. You can take that out of there and download it in your computer, and there's a GoPro software, and you can make great footage with your GoPro Hero.
That's great.
And your DJ Phantom 2.
And how did you get interested in flying?
I've been flying with Discover RC for probably 7, 8, 9 years, and just got into quadcopters. And my girlfriend's into aerial photography, so we put the two together, and we've got a DJI Phantom with a GoPro Hero. We're have a great time with this.
That's neat. And where do you look to for supplies for your flying?
Most of this stuff you can get directly from Phantom. You can get it from the best place is Amazon. Amazon Prime, 2-day shipping. You get all this stuff. That's where this stuff all came from.
What kinds of things would you search for on Amazon or another site to be able to find the right kinds of things?
You can get the GoPro, you can get the batteries, you can get the props, you can get the prop guards, you can get replacement equipment, you can get any of the internal wiring harnesses available easily on Amazon. Or directly from Phantom, and there's a whole bunch of other hobby supply stores where you can get this kind of stuff.
How do you get in touch with the club?
Discover Flying RC Club, you can go right to our website, and the contact information is right there. And we're in Marston's Mills, right by the airport.
All right. Well, thank you very much.